here's Khan Academy, and here's Desmos. All right, so here's Khan Academy. All right, here's Khan Academy. Whoa, this is Calc 2, right? But here's the thing. So this here is a series expansion for e to the x. A series here, this series looks like an infinite polynomial. It has infinitely many terms. This here is a series for cosine of x. This here is a series for sine of x. Now, so if you take many terms and you plug in values for x, you get an approximation. Now, if you don't believe me, let's build this up. Let's look at sine of x. I claim that sine of x looks like this infinite polynomial. This is a series. Let's go term by term. I'm going to build it up term by term. Here's our old friend. Oh, I should put in projector mode. All right. Here's our old friend, y equals sine of x, the sine wave, right? Let's look at the origin when x is 0. Let's look at the origin. What's the best linear approximation to the graph near the origin? It's the tangent line given by y equals x. That's the first term in the series. What if we take the first two terms? That's in black. See, it's starting to hug the red sine wave a bit more. What if I take the first three terms in the series for sine of x? This is Calc 2. That's in red. How about the first four terms? That's in blue. It's hugging the curve more and more. By the way, factorial means it's like, 3 factorial is 3 times 2 times 1. We'll review that. 5 factorial is 5 times 4 times 3 times 2 times 1. We'll review that. But these series, notice, as you take more terms, we're going to hug this sine wave more and more as we go outside. Same for cosine. Okay, at 0, 1, projector mode, all right. At 0, 1, all right, this point here, the tangent line is flat. All right, if we zoom in, right, the cosine curve looks really flat up there, right? Okay, so the tangent line's flat up there. How about if we take the first two terms of the series? Okay, we're getting that parabola, right? It's a nice fit. Best quadratic approximation near this y-intercept. All right, how about the first three terms? That's a good fourth degree guy. It's hugging that cosine curve better and better. How about the first four terms? 6th degree. That's the best 6th degree approximation near the point. All right. So as we take more and more terms, right, it's like we're getting a higher and higher degree polynomial, and we're going to fit this cosine wave better and better as we start moving outward. And we get really good approximations near 0, 1. This is called a Maclaurin series. A Maclaurin series. It's a Taylor series centered at x equals 0. All right. Now let's talk about why e to the ix was cis of x. Remember that, Jazz? Khan's going to explain. So now here's the deal. I'm going to pause the recording,